Hello student, welcome to all of you in next physics lecture, video number 11. Myself, Mr. Rajesh Lagat, physics teacher. We have to see here the chapter number 1, rotational dynamics. In previous lecture, we have to see the principle of parallel axis and the perpendicular axis. This is very important. You can see this and you have to also well understand. Then the next point is the angular momentum. We have to ask in question, there are the relation between the angular momentum and the angular velocity, that is the L is equal to I into omega, where L is the angular momentum, I is the moment of inertia and omega is the angular velocity. Now, we have to see here the diagram for this angular momentum. We have to consider here the rigid body which can be rotate about its axis of rotation, but with the constant angular velocity omega. This rigid body which can be rotate about its axis with the constant angular velocity omega. All these axes which are passing through the point O and perpendicular to the plane of figure. All these axes which can be passing through the point O and which are perpendicular to this plane of figure. We have to consider here this rigid body which can be the consist of n particles of masses m1, m2, m3 ... mn situated at a distances r1, r2, r3 ... rn from the axis of rotation. All these distances from this m to o r1, m2 to o r2 like this ... r1, r2, r3 ... rn. We have to see here this rigid body which is consist of n particles of masses m1, m2, m3 ... mn situated at a distances r1, r2, r3 ... rn from the axis of rotation. Here we have to turn this derivation for the mathematical steps. Remember, as the body which can be rotated with the constant angular velocity omega, then again the linear velocity for the first particle which is given by, and we know the relation for the linear velocity for the first particle which is given by v1 is equal to r1 omega, because the omega is a constant, so that we can write here only v1 is equal to r1 omega. Similarly, we can write also v2 is equal to r2 omega, v3 is equal to r3 omega ... so on. Then the linear momentum for the first particles you seen in 11th standard, the linear momentum. This is nothing but linear momentum is the product of mass and the velocity. Linear momentum, it is nothing but it is the product of mass and velocity, so that we can write here linear momentum for the first particle is given by P1 is equal to m1 v1. Instead of v1, we can write here v1 is equal to r1 omega. Substitute here v1. Therefore, p1 is equal to m1. Instead of v1, we can write r1 omega. Substitute here, then p1 is equal to m1 r1 omega. This is nothing but the linear momentum for the first particle. First particle, mass m1, radius, that is the distance r1, so that we can write here p1 is equal to m1 r1 omega. Also, we can write for the second particle p2 is equal to, this is the linear momentum for the second particle, p2 is equal to m2 r2 omega. Okay, understand? This is the linear momentum for the first and the second particle, that is the p1 is equal to m1 r1 omega and p2 is equal to m2 r2 omega. Then we have to find out the moment of linear momentum. Then what is meant by the moment of linear momentum? The moment of linear momentum is nothing but it is the product of linear momentum and moment arm. This moment arm is nothing but also it is the perpendicular distance, that is the r1, r2, r3. This is the moment arm, this is the perpendicular distance. So that moment of linear momentum of this particle is the product of linear momentum and moment arm. And so that we can write here this L1 is equal to P1 into R1, where P1 is what? Linear momentum for the first particle, and R1 is what? This is the perpendicular distance, or this is also called as moment arm. Therefore, L1 is equal to P1 into R1. Then we can substitute the value of P1. We can find out here P1. What is the value of the P1? P1 is equal to M1 R1 omega. Substitute instead of this P1. L1 is equal to P1, instead of P1 we can write here for what? M1 R1 omega into R1. R1 into R1, R1 square. Therefore, we can write here L1 is equal to M1 R1 square omega. This is the moment of linear momentum for the first particle is given by L1 is equal to M1 R1 square omega. Similarly, we can find out the moment of linear momentum for the second particle, and we can directly write here the L2 is equal to M2 R2 square omega. This is second particle, therefore, we can write here M2 R2 square and the omega. Dot dot dot, we can also find out this ln. Ln is nothing but what? That is equal to Mn Rn square omega. In this way, we can find out the moment of linear momentum. L1 is equal to M1 R1 square omega, L2 is equal to M2 R2 square omega, also dot dot Ln is equal to Mn Rn square omega. Then the sum of moment of linear momentum of all the particles, which is called as the angular momentum. We have to derive the relation for the angular momentum. Then this angular momentum is nothing but sum of moment of linear momentum of all the particles is called as the angular momentum, denoted by the letter L. Therefore, we can write here this capital L is equal to L1 plus L2 plus dot 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 Ln. This is nothing but the angular momentum, that is the sum of moment of all the particles, sum of moment of linear momentum of all the particles, that is given by L is equal to L1 plus L2 plus dot dot Ln. Substituting these values of L1, L2 and Ln, we get L is equal to, instead of L1 we can write M1 R1 square omega, plus instead of L2 we can write here M2 R2 square omega, plus dot 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 Mn Rn square omega. Then we can take out the common omega, and we can write simply L is equal to, in bracket, M1 R1 square plus M2 R2 square plus dot dot Mn Rn square and common omega. That is the angular velocity. Then this bracket is nothing but M1 R1 square plus M2 R2 square plus dot dot Mn Rn square. This is nothing but the sum of product of moment of inertia, that is the mass of each particle and the square of distance from the axis of rotation, and that is nothing but the moment of inertia. And therefore, instead of this bracket we can write L is equal to summation I is equal to 1 to n mi Ri square and into omega, and this bracket is nothing but moment of inertia I, and substituting this I instead of this bracket we get L is equal to I into omega, where L is the angular momentum, I is the moment of inertia and omega is the angular velocity. This is the relation for angular momentum, L is equal to I into omega. In this point, this angular momentum L is equal to I omega, you have to find out the change in angular momentum in numerical. This formula is very, very important, and you can solve this problem by using this formula L is equal to I omega. You have to understand this. Thank you.